Hello everyone. Today I'm going to be taking on the chess challenge by SebastianLague to create a chess bot in a month. Here we go. So I am going to start out by playing the chess bot that is already in here. And I'm about 2,000 on chess.com, so this shouldn't be a problem for me to beat. Oh. That's nice. So I'm actually going to replace the code from my bot with EvilBot. So this is just EvilBot's code, but I replaced the name with my bot. And now I should just be playing EvilBot, but it's going to be called my bot. So already it's not getting mated so fast. Let me try this. Yeah, okay. It's going to get mated anyway. So, yeah, it's still not playing the best chess yet, but I have an idea to fix that. So I've taken a look at EvilBot's code, and basically what it's doing is getting a list of all the legal moves in the position, and then playing a move at random if it doesn't find anything better, and then it is playing checkmate in 1 if it has checkmate in 1, and then if it can capture a piece, then it will always capture the piece, and it will always capture the highest value piece. And this is just how it just checks for checkmate. So now that I know this, it's not really evaluating the position. It's just playing random moves if it doesn't know what to play. And then if it can capture a piece, it will. If it can checkmate, it will. So let's think of something that we can do to fix that. So I'm looking at the chess programming wiki to find an evaluation function, and right now I'm looking at material score because material is one of the most important things in chess. If you have a queen versus a rook, a queen is obviously a lot better than a rook. So usually material is the biggest part of an evaluation function in chess. There are exceptions, but usually material is the most important part of evaluation. So, what I've done is I've started an evaluation function for my chess program. Okay, so what I've done here to make an evaluation function is to get a piece list of every single piece and count the number of pieces in that list. Once I got the number of pieces in that list of all of these types, then I'm going to return the sum of all the pieces and their values. Okay, now I have the evaluation function, but now I want to use it. So how do I go about that? Well, I start by having all of the piece values inside of this list, and then I'm also going to store the current evaluation and the best evaluation. And so we're going to start with having legal moves equal to board.getLegalMoves, and then we're going to have the best move equal to the first legal move in the position. And by default, we're going to set the best possible evaluation to the lowest evaluation, because if we set the best evaluation to the lowest evaluation, then automatically, whenever we set this current evaluation, it's going to be the lowest evaluation. So it's going to go straight up and call that and make the current evaluation the best evaluation. So now that we've gotten the best evaluation, we're going to make it the best move, and we're going to do that for each move in legal moves. And then we're also going to do the opposite if it's black's move, and then we're going to return the best move. And here's just the same evaluation function that I showed earlier. So now I'm gonna play the chess bot. Okay, let's see if it's actually better than EvilBot. I guess not. So the reason why it's playing even worse than EvilBot now is because of this. It's only making one move and evaluating the position after that move. But it could just make a move and then completely blunder a piece after that move. Let me just show you, for example. So if I take this, it's going to take back because it's giving an evaluation of 0 after that position. But look, it thinks that this is -1 right here. It thinks that this is -1 because it's won a pawn. But it hasn't actually won a pawn because it doesn't see my next move is to win the rook. And so now it's going to say 3 once I push this pawn. See, it has a 3 right here because I just pushed this pawn. And then now whenever I take this, it's going to be 7. Or 6, I guess. I forgot about that. So, how are we going to evaluate the positions in greater depth? Introducing minimax. So this is actually used in a lot of turn-based games, and we're going to use it specifically here in chess. So let's say we're going to start at the bottom here, and we're going to have an evaluation of -1 here and -2. And so we are going to assume best play from our opponent. So that means that they're going to go for the minimum. And of course, that's going to be -2. So -2. And let's say we have -3 right here. Well, we know that from right here, we're going to try to go for the max. So we're never going to go down a branch that's going to give us a -3. So we can just prune this, which is called alpha-beta pruning. Now let's say we have a 2 here, and we're going to have to evaluate this one, so let's say it's a 3. And so this guy is going to go for the minimum of the 2, and that's going to be a 2. And then let's say we have a -6 here, but remember, this guy is never going to want to go to a -6 because we already have, I guess we have a 2 now. So we're not going to want to go for a -6, so we can go ahead and prune that branch. So the best possible evaluation is going to be a 2. So now I've just implemented minimax, and now it's going to be going off of what minimax suggests. So the thing is, I haven't really put any positional play into the bot, so I wonder how good it's going to do just off of knowing material. I'm gonna go here. I'm gonna go like here. Yeah, it doesn't really understand the concept of like king safety. Yeah, its king is way out. Yeah, what is this? There's gotta be something here. Maybe if I do this, I have this, and I can take the knight. Aha. So it's sacrificing its piece because it didn't really have much better to do. That's a tricky move. Let's go here, and here, and here. And there should be a mate somewhere. Yep, that's mate. There we go. So the bot doesn't have very good positional play, but it does understand material. So I know there was an improvement of the bot, but just to check, I'm going to put it up against EvilBot to see how much of an improvement there was. So my bot actually won against EvilBot 10-0, which is called an adoption, but still, it didn't beat me. And I'm good, but not that good compared to someone like Hikaru Nakamura. So it still has a lot of improvement to do for it to even come close to winning this competition. To see how I improve it, you'll have to wait till the next video. See you there.